Hello. Hey guys and girls. Um, yeah, so welcome to the Swivel Workshop. And when I was asked to, ask if what do you want to talk about, what would be some things you want to do a workshop on, I felt like, based on, everybody going to college, this was an important topic because I've been here. And, when you have teams, when you're building a project, when you have course assignments, it's hard to work with other people. And it's one of the things that, probably may get overlooked when you're in computer science because, we talk about the tech, we talk about the why, we talk about the how, but essentially, each organization that I've been part of, so I've been part of a 3-person tech team to a multi-huge company where there are multiple floors of developers, right? So essentially, nobody actually works by themselves when you're writing software. Anything you touch, anything you're using, your laptops, your phones, has software, right? Software is never written by one person. That's mostly true. So what everybody knows about, all the topics, like we learn about everything. This is probably something I want to focus on. Like, hey, if it's a bunch of people in college, I really want to talk about, hey, how do you really contribute to software development together? It's a big question, right? Because everybody has ideas, everybody wants to do it a certain way, everybody has code. So how do we actually work together and how do we ship software, right? And being part of Swivel, we ship software every week. Uh, you know, want to understand and help you guys ask us about how do you actually manage to do that, right? What are the things that are involved into shipping software? Because software cannot break, and then Swivel is a fintech organization, so it's very important that we get stuff right, right? So I want to introduce myself. So my name is Faisal, and I'm a senior software architect at Swivel. And I was just counting, it's been a while since I was a freshman, and I think it's been a while since since we've been learning, since being introduced to formal education with computer science. Because I've obviously worked on the small projects when in high school, but formal education and everything. So I've been a software engineer for around 15, 16 years. Learned about the trade. I've programmed Python and JavaScript, C Sharp. The languages have not been consistent for me. It's all about what the problem is and how do you solve it. I've done one project on PHP, very bad. So stuff like that is where we've looked at a lot of stuff. We have to debug. We have to look at things, and yeah, based on the experience, I wanted to have you guys get access to somebody from the industry and ask questions, right? So yeah, so the idea is to talk about how to write software collaboratively, right? So some of the things we're going to talk about today are these things: version control, clear communication. How many guys were you part of the Git workshop that was in there? You guys, okay? So have you mostly guys work with Git? More or less. So it's spread. Okay. So I think version control and then clear communication. Most importantly, coding standards, right? So we got to talk about how when we are reading code, we're also writing code, right? Because it has to look and make sense. So coding standards is important. We'll get to that one. Um, Something that we never think about, right? And we talk about the importance of why. But when you have an idea, when you're churning out the code, design is not something you do. And having modularity in it is very important, and we'll talk about why. Flexibility feedback. This pertains to working collaboratively. When you're working with somebody else, you got to have some flexibility. There's feedback that you're going to get from product owners, stakeholders, your peers about what your code is and does and how it can be better. So we're going to talk about that a bit. And testing and QA. Nobody does, right? Before we ship, we got to have some idea of what we're trying to ship, what we're trying to solve, and does our software actually do what we say it does? So we're going to talk a little bit. And yeah, so this workshop is not intended. I don't want you to be thinking that I'm going to have to write some code. It's going to be a collaborative session where we're going to ask questions and we're going to stop and we're going to understand something before we move on, right? So the whole idea is to understand the whys, what we do, right? So do all of this in a actual organization. So number one, version control. So I was looking at some memes, right? So I was looking at programmer humor. And I was like, dude, I need some memes to explain, like to get through to like what are the problems we see. So I saw this one as on, I think this was like a few days ago. So in the spirit of Halloween, somebody had carved a pumpkin, and this was the scariest pumpkin to a developer. Git push -F. So Zach is going to give his T-shirt. If somebody can answer, why is this so scary? Super scary. Yes, please. Okay. So what's your name? Sorry, Martin. So Martin says that when you're pushing, you might break something, you don't know what's going on, you don't know where. So essentially, what this is, and he's exactly right, right? So you're forcing the push. You're saying that my commit overrides everything else. So everybody's collaborating, and then everybody has their version of code. They pulled it down, they got it to work. But what you're doing right now is you're overriding everybody else. This is scary because this is when stuff breaks, because everybody else has been working on their piece of code. So this is super scary. So Martin, that got right. Perfect. Thank you so much. So yeah. So first thing is, so the idea of version control. Let's talk about it actually. So you're working on a project. When you decide to say, hey, this is not a one-person code, well, it's never going to be one person because you're going to share it with other team members. You're going to push it to Git to get some, like, hey, this is my personal project. Please contribute to it. Good idea. So it's. Do you guys know why we use version control? So what are the things that might have happened in the industry to say adopt like a series of tools called version control? Well, you got to have software working, right? So if anybody else has made any changes, they got to compile it and make sure it works. So whenever you push something, you make sure you don't break the software. So version control ensures that person A and person B are working together, and they can manage the whole code base together. But when they want to contribute to a release, right, or to code to say, hey, this is a combined version of my code A and the other person's code B. Do they even work together, right? So version control makes sure that it's able to see the differences in files, right? It's able to say, okay, main.py, let's say we were looking at this previous example of Python, right? So Python has an entry point, and Python is the main file that says, this is how I start up. There are two people wanting to import different libraries and have different dependencies. So when you have version control, you can see the difference on person A use this module, the person B use this module. And then the idea is you want to merge both of their code and see if it even works, right? Because does it work? I don't know. Because A has worked on their piece of code. They can say it works. B says, no, my feature, the thing I was working on, it also works. But when you push it together, does it work? We'll find out. This is why at least we know that we can go back to something because we have version control. If it works and how it works and how do companies make sure that it does, we're going to talk about it a little bit later. But essentially, it is a version of code. They actually contribute to a feature. You are going to merge it with somebody else's code, which also contributing a feature. So version control helps you maintain what everybody did so that, most importantly, you can go back to when it was working, right? Okay. So using Git, pretty straightforward. Everybody's contributing, have their own version of the code. They contribute together. So you have some software that manages the versions between people. Branching strategies. So I said something about releasing code, right? Different companies have a different flavor of branching strategies, but these are Gitflow is probably one of the GitHub and all of they have established guidelines of, hey, this is a good way to do things, right? It doesn't mean that that's widely followed. It means that every place has a different process of what they want to follow. So what is a branching strategy? So anybody here have any idea what a branching strategy is? That's fine. So what is a branching strategy? So essentially, there are multiple versions of the code. There's one product, but there are different versions. So essentially, there are features that keep getting added by different people, right? But what do you release? How do you find out what to release? Whose version makes it to production? Yeah, please, Martin. Main. Okay, so main. So main is your default branch in GitHub, right? So main is your default branch, and that's your first branching strategy of everything that you get off main. So you basically clone and create a branch off main. Basically says, okay, this is the point in time that main worked. Got to make sure main always works. So at the point in time when you said, okay, I'm going to fork this. So your first branching strategy is I'm going to create a branch from this version of the code and right? Start adding to my code, right? That's your main thing. If you're going to push back to master, it better work, right? Number one. But this is not the only branching strategy. Branching strategies are, hey, we don't want to do that. Master is very volatile, and what master should always reflect what's in code and what's been tested, what's been deployed. So different companies do different things. But essentially, what the intent is to talk about at what point do people want to contribute? Do they say, okay, this is a good point in time. I'm going to fork off this. I'm going to write my code. And I'm going to try to push it back. Or I'm going to push it to somewhere else where we can test it and see if it's good, and then push it to master once we deploy. Stuff like that is where there are different strategies, different things, different companies, different developers come together and say, hey, this is what I like, right? This is, or we don't have a whole department who checks our code, so we're going to do it differently. But essentially, it's a group of developers coming together and saying, okay, this is how we ensure that everybody's merged. When they merge together, stuff works, right? Pretty simple, but that's a branching strategy. So essentially, two parts of, like, hey, how do we make sure versions? You're writing code, right? So when you're writing code, you're making all these contributions. You got to make sure if it works with somebody else's code. A branching strategy is as important as using the base tool. So you got to understand how your code moves forward. So any questions? Make sense? Makes sense, right? I mean, yeah, we got to push code together. There must be, a flow of, how we want to branch off and then push it back again so everybody's code gets tested. But yeah, those things we want to talk about. Okay, let's move forward. Clear communication, interesting. Clear communication. So let's talk about the regular updates, right? First thing is, every day, every morning, what do? We get together. So as developers, we get together, we say, okay, I was working on that issue yesterday. What happened? I couldn't fix it. Okay, so what happened? So then you talk about clear communication on what your approach is. So I'm trying to solve a problem, and approach A didn't work. So you go back to your developers, you go back to your team, and you say, hey, this did not work for me. Do you guys know what I should try? Or, hey, this is something I was actually working on, and it did get working, right? This is what I did. So every day, there's regular updates on where I am, what I'm doing, and where am I stuck. That's very important in collaborating in a team, because if you're stuck and somebody else has solved the problem, why waste all that energy, right? If somebody has information on how this stuff works, well, what do you ask them? What should I ask them? Like, let's say some my developer says, hey, this is obscure problem, my file IO doesn't work, and it throws this exception because of this missing dependency. I got it to work like this. So what is the first thing as a fellow developer? What should you say? Yay, good. What is the second thing? Can you write a doc for me? Can you write that down? Because I'll forget, right? You'll forget. Because tomorrow there'll be a different issue, you'll forget. So that leads us into documentation, right? Documentation. Okay. Has anybody have experience writing readmes? Writing readmes. Have you ever written a readme? Oh, no, not yet. Martin, yeah. Okay. So have you read a bunch of readmes then? Okay, good. So what is the point that people are trying to communicate there?
The documentation about the project.
Okay, documentation about the project. Well, that's understood. But what is the information about the project?
Yeah, like how we can implement the project in our local systems.
Okay. So how do you run it?
Yeah.
Okay. Have you ever read the README and you followed the steps and it didn't run? That's so infuriating. You're like, dude, you told me what to do. It doesn't work. What do? You don't give a star. Like GitHub, you don't get a star. Okay. I mean, that's why you have issues, right? What's the second thing, right? Issue tracking. You're like, hey, you told me how this works. This fails on this command, right? So GitHub has this place called issues. Have you, so GitHub and other bug tracking, like if you use different platforms like Bitbucket or anything, and any place that holds Git, right? They track issues. The issues are like, hey, you can place a line, place a comment that, hey, I tried this does not work. Issue tracking is important. It's not even, it's important when your product has bugs. Everything you ship has some edge cases that you might have missed. That's absolutely true. That's always going to happen, right? But those are issues that you're going to track, but you're also going to track about, hey, this is something that as a fellow developer, dude, you told me that this should work like this. This is false. I do not like this project at all, right? Stuff like that is where people contribute to pushing the code forward, right? So code comments. Has anybody ever had to deal with the scary concept of code comments? You know what happens in code comments? So you write this function, right? You write this fancy function, and you have this line in there that does a bunch of things, and your fellow developer says, "Boop, you know what? You should refactor this," and you're like, "Oh no, what do you mean you want to refactor this?" They're like, "Hey, I don't understand what's going on." Like, so, but it does the job, right? It's got the tests pass. Like, no, please refactor it. So code comments are a way for a developer to communicate to another developer to say, "Hey, I don't really get what's going on here, right? Or can you please use a different style or a different thing that you use? Or maybe your variable name is awful, right? Can you write something better that is better well suited to what it is?" Essentially, code comments are before you accept developer B's code into the main line and say, "Yes, we are going to maintain this code." It's an opportunity for all developers to have some ideas about what it should be, right? And we're going to talk about coding standards next. But essentially, this is what it is. Code comments are a way to communicate, way to explain and say, "Hey, if we're going to be writing this code together, you might want to change this because this is not well understood." Because I've written fancy lines that do multiple things in one line. I thought I was pretty cool. But in enterprise software development, they don't like it. Anybody have any idea why? Yes, please. Absolutely. It's confusing to other people. I might be fancy, but if the code is not well understood, what will happen? You get bugs. They think it's different, or you can't make changes to it. It's absolutely not what it should be. So if it's the first idea of writing code is, as in the enterprise, the intention is to write maintainable code. It's going to function. It's going to be 2 lines longer, but it's going to be maintainable. And that's a trade-off we always want to take, right? And that's some of the feedback I've gotten from my fellow developers to say, "Hey, can you clarify what you're trying to do here?" And I think code comments are also when you talk about commenting in your own code, right? When you say, "Hey, this is what it should do," I really have a very nuanced opinion about what it should be. If you have to write a comment about your code, well then, is your code doing what it's supposed to? Because if you have to explain it, sometimes you don't, right? Sometimes if you write a line and say that this is what I'm trying to do here, well, shouldn't your code say what it's trying to do here? If you're iterating over an array and you're doing an operator function or something on it, and if it's something that you have to write a comment, "I am taking and deleting the first entry of the array," then either it's redundant, right? Or it's unnecessary, or it's over-explaining it, right? Because your code should be clean enough to say deleting last object or whatever your variable names, code should be self-explaining. But code comments, right, are a very good way to explain what your code is doing, right? And yeah, the pull request code comments are pretty cool. Those are also things. Let's go to the next one. I think I want to talk about coding standards. Something I alluded to, right? You have 2 variables doing the same thing. What's going on, right? Because what's the whole point of writing 2 variables that do the same thing? Well, that's where you're of writing the code. So coding conventions. Okay. Coding conventions. Every language. What are the languages that you guys are most familiar with? Python? Python? Python, Java? Okay. So mostly companies like Airbnb, Microsoft, many places where they write a lot of code, they sort of have been over this cycle a lot. They've been trying to talk to developers, and they've been like, "Hey, we got to write the code that looks similar, or at least follows the standard, because some person is writing a variable name like this, some person is writing a variable like that." But overall, it becomes hard to maintain, hard to read, and everybody gets confused, and it's more time looking at code that you need to understand. So these big companies, what they did was, hey, decided on, hey, what do we like? How many spaces do you want? I was trying to find a meme on spaces versus tabs. Do you guys know what the issue is with people spaces versus tabs? They are, but what is the whole argument? So there are 2 sides of the camp. One, people say your code should be indented with spaces, and one say that it should be indented with tabs. And as Martin said, yes, please. Yeah. so annoying, right? Spaces are inconsistent, right? So essentially, what somebody solved the problem was a tab character was replaced with either 2 spaces or 4 spaces to get both camps to not start talking to each other, because people are very opinionated about this. Like, no, tabs are important, and these oldies from the 80s, they will swear by it. There's a whole camp about tabs versus spaces, and like when I see that tabs being introduced, because I've had issues with the tab character not being replaced by my IDE into a spaces, and then you also have to agree on how many spaces. But regardless going into the minutia of tabs and spaces, the idea is that everybody agrees that this is what your style should be, right? So Microsoft, all of this based on your language, based on Java or Python, somebody has a styling guide. You can always change it. There are tools called linters that you can install on your own repository and say, hey, why don't you style this code, and your ID will give recommendations. VS Code is pretty cool. You guys usually use VS Code. What do you guys use? VS Code, yeah, it's pretty simple, right? Lots of extensions, lots of tooling out there, but essentially all the code, at least before you commit, before you push the code, you get like little errors and warnings that says, hey, can you consider changing this line, because it's not applying to convention. So many compilers also throw these warnings to say that you're not conforming to the standard, and if you still want to push this code to a pull request review, well, somebody will tell you, like, hey, you're not following this, because lots of code reviews and code comments are, with Zach, there was a bunch of, hey, you missed a space here, or your semicolon's out, and there's lots of, code reviews, just that, like formatting, like somebody will tell you your formatting is wrong. What do? You install a linter, make sure it's always there. So, code reviews. Okay. So code reviews are what we talked about, right? Code comments, about people other giving comments, also inline comments. But code reviews are essentially what we talked about people looking at other people's code. They get the time to review your code. They get to give you feedback, and it's a very important thing you should do, because well, people say that their code is working. You got to see if it works. You got to see the function. You got to see everything. You got to see the dependencies. There are lots of things you got to follow to see if it actually works, right? So pull requests are the same thing we talked about. So, any questions on this one? Coding standards? Any tooling? Yes, please. Eclipse is IDE, yeah. So Eclipse is an integrated developer environment, which is like VS Code, and it has a bunch of tools. So essentially, it'll give you linting and everything, and I'm sure it has extensions. But yeah, Java folks like Eclipse, yeah. Okay. Yeah. Yeah. Yeah, if you're doing iOS apps, you have like Xcode, right? And yeah, exactly. So every environment has whole tooling. Everybody's like, hey, let's make our job easier. So there's either provided by the manufacturer, like Apple does that. Android Studio is for Android development, so they do that. But yeah, every people, every team has come together and made each other's life easier, right? So how to compile, add these tools and everything, and are making life for developers easier. Okay, this one is actually what I do all day. Right? That's what we talk about as architects, right? So it's a conversation that we have to talk about on every level, right? How big is your function? How big is your module? How big is your service? How big is your solution, right? So all those things we talk about of how big is big, right? And you maintain it. So have you guys ever, looked at, or like haven't gotten that feedback that your function is too big, or you're doing too much here? Okay, so please talk about that. What are you making? Making beginner classes? Yeah. Okay. That's true. Looking at a coding level, right? So you can look at explicit statements and see if you can optimize them. But essentially, what I'm talking about is more of what you're trying to do there, right? So if you have a function, let's say, that says calculate tax, right? What should it do? Just calculate tax, right? If you have a function that says add two numbers, it shouldn't be doing extra things. So what you're trying to do and what you're trying to achieve, plugin function that says I do all the things that you want to do. You can have a huge main.py that says I am exactly doing what you're supposed to do. So let's say if I'm writing an image, let's say I'm writing something that like Instagram, right? So I take an image and I upload it to my server, so for everybody else to consume. Let's say if I have an entry point that does say, hey, these are my followers, you can publish it to these people, but also in the same function you're doing image encoding tasks, or you're trying to clean up the text, and you're going to see if it matches with some banned keywords. There are many things you might need to do when you're uploading a post, right? But when you're organizing the code, there are different reasons why you're writing the code, right? So you got to modularize what you're trying to do, and at a level where it's a function, right? So many of statements of this is what we're trying to do versus hey, we're doing too much here. What are we actually trying to do? And we'll find out why it's important, right? I think it leads into the question of if you're out of function, can I test it? If it's doing too many things, your test is doing too many things, right? So you gotta make them loosely coupled, right? Which talks about the second one, loose coupling. Okay, this one is a hard one, I'll be honest. We struggle to get this right a lot, right? Because it's very arbitrary. Loose coupling is generally talks about what your dependencies are. So let's say let's talk about an example about this Instagram app, right? Hey, I'm trying to divide the work, okay? And I'm going to say, hey, you're going to work on image encoding or compression or whatever, right? And developer B is going to work on something else. Let's say they're going to check for the banned word list or just checking for hashtags, right? So whatever you're doing, there has to be a separation between what you're doing, right? Loose coupling just talks about if two people can collaborate together, they have to talk about what are they going to exchange, right? They're going to talk about it, something called an interface. Hey, I'm going to send you information on your API. I'm going to send you image IDs, and I'm going to send you the text. But you can build your text recognition software, right? That says this is this, right? So essentially, when you're trying to work together in systems, right? The less dependencies you have is better for people to independently work on them, right? There's always going to be some sort of coupling between two services, right? Because again, I got to fulfill the request. I got to do the image recognition, right? I got to do some things on it. But that's the point where you try to talk about, hey, what are we actually trying to do here, right? So loose coupling ensures that software can grow without, without us changing too many things at the same time. I don't know if I'm making sense, but essentially, if you're doing big things and things are together, then I'm changing a whole bunch of software. But if it's modular, if it's separate, if it's loosely coupled, if your interfaces are defined, then what you do is, people can be independent, their modules can be independent, they can be tested, and we can always test the interface. We can say, hey, let's just send the file name and import and see if it works. So anyway, loose coupling is important. I think the more you guys get into the habit of, writing big scale systems, it'll be more apparent there to say that, okay, my software is totally dependent on what your input is. The question is, should it be? Well, no. Well, then you make it looser. And that's what we're talking about, right? Because inherently, software that is being written together is always going to be coupled because you're doing the same things and fulfilling some similar outcome. But looser is the key word here, right? You don't want a hard dependency that, hey, if that service is not online immediately, my stuff is going to fail. Well, that's a hard dependency, right? That makes sure that whenever you deploy, that's a very risky service, and you got to make sure that everything's working, and it's more risky, right? Yeah, looser stuff. If that stuff is off, it's not working, it doesn't bomb this service. That's very important, right? That your stuff is still available and for people to use. Um, I, this has been a good year, honestly. I was trying to think about many outages that happened. But yeah, I don't think it's the CrowdStrike one is very relevant to this conversation. But yeah, maybe we'll talk about it in testing in QA. That was a pretty fun one, where all the airports were out, and this security software made sure that every person who was trying to check somebody into, to their flight, it was a blue screen of death. So we'll talk about it in testing in QA. But this has been a good year in terms of, like design issues and stuff. Like I feel like less issues are this year. But maybe if I'll think of something, well, if something that leads to, hey, our dependency was so hard on the other system that everything crashed, right? We'll think about that one. I think AWS had something with the IAM, but we'll come back to that. Okay. It, That's a great example. That's a great example. So there was a central database that held a bunch of information, and other systems at other dealerships, right, were not working due to this core dependency. So they're very tightly coupled. If that service didn't work, everybody was sitting and doing nothing. That's very important. I don't know about the exact architecture there, but let's think about it, right? That service where it holds everybody's information was unavailable. Should it stop a person from their job of selling cars, or servicing cars, or putting information into the system? No. You should always be available. If that's not available, you can say, hey, this service is unavailable right now. It shouldn't crash your software. Never, right? There are many software that is very key components, right? Like authentication software has to be there. You cannot say that you should be able to access a service without authenticating. Like that would not make sense. If the authentication service is down, I get it. It's an outage, right? You shouldn't be able to give random people access to your sites just because your auth service is down. Well, auth service needs to be bulletproof. And that's a whole concept of open specs and everything. But the auth service is important. Simple database of information, well, that's not as important, right? I should be able to take bookings and stuff. So that's a very good example of looser coupling. That's very important. So we'll see. That's a great example. Thank you. Okay. Okay. Oof, humility. Oof, it's a hard word, huh? Every software developer, programmer would, was like, oh, humility. Okay. It's a hard one. Okay, so this happens a lot, unfortunately, and this is a second thing to do more often. But yeah, let's talk about the open to feedback, right? So I wrote a bunch of software, right? I figured a bunch of stuff out. I said, oh, this is the perfect decoder to use, and this is so good, it's going to be so optimal, right? And I say, dude, this is what we're doing, and this is in my pull request. Like, hey, this is what we're doing. But, that might not be the best idea. Reasons would be, compute, speed, capacity, cost, many other things. Your code is beautiful, but do we actually need to do this right now? It's a lot of questions, right? So I can be angry. I can be like, no, dude, you don't know what you're doing. This is the best code ever. What are you talking about? Humility, right? I mean, it's all about understanding the feedback. The person's talking to you and telling you something. There must be a reason, right? They want to talk. I mean, I've been in a room full of developers all my life, right? People don't want to talk to each other, right? They're like, yeah, you're fine. So there's a reason why he's coming up to you and wanting to engage in a conversation that he feels is important, he or she, right? That they feel it's important to talk about. And it might be something there you might need to listen to, right? It's not something that you're thinking about. Might be a perspective you lack right now, right? But it's important. What is the intention? To ship good software. That's the intention. There are many factors and there are many perspectives. It's a great idea to listen to the other person. And humility is, I swear to you, it's very hard, right? Because, accepting feedback is hard. Sometimes it is, so, but it's important, right? Similarly, if you feel like some code must be written in a specific way, and you're reviewing somebody else's code, they've not done it the way you thought it would be written, right? Well, what do? You write a comment. Hey, this is probably not the best way to implement this. Can you use it this way, right? Maybe it's not the best idea based on time, based on some information you didn't know. Probably you didn't read the ticket, right? And there's some reasons of why it's being done like that. But it's good to understand, like, hey, okay, I get it. It makes sense. Let's move forward. That's the idea, right? To accept it, the work's done. There's a trade-off. Do we spend more time rewriting it? Well, maybe not today. Maybe we will. That's a conversation for you to get on the same page on. Hey, do we do this now? Or do we think it's not a thing that we should ever touch? It's a conversation. Always important, right? Okay. Yeah, any questions? That's a simple one, right? That's pretty simple. I don't think you have any questions on that one. Iterate often. Oof. That's a hard one, dude. Iterate often. Okay, so have you seen like software with version numbers 1.19.765, whatever, blah, blah, blah? Have you guys seen any, have you ever seen, encountered any version numbers? Okay, so essentially what you can do is, simple, is you have a bunch of developers. How many developers on this line? 1, 2, 3, 4, 5, 6, 7. 7 developers working together on a product, right? And we're shipping and we're shipping and we're shipping, right? We're shipping every week. We're saying, this is good. What do we have? 7 features or 6 features, or maybe people work together on a feature, right? What's going on? More things are changing, right? So let's say it's Instagram, right? You're introducing per version change a bunch of code change, right? People have people on Instagram or different types of phones. Do we see that it might be an issue somewhere, right? So let's say it's an issue with file I/O. Let's say every OS is different, and it was supposed to read a file on the disk and it just crashed, right? But there are 7 features we tested. It's more risky when you're pushing bigger chunks of code that is new into the world out there, into the user that is going to use it however they want to use it. It's risk, right? So this is important for orgs to understand, right? And as people who write it, it's important for us to think about our projects and also understand the smaller changes I push out, it's easier to roll back. Say, oh, 0.5 of the feature didn't work, that's fine, we can work on the next one. If it's easy, it's easy to push, easy to move forward, easy to test, and easy to roll back, that's more dependable, right? So when you're improving software, the idea was once that we wrote pages and pages of requirements, a 6-month exercise of, hey, product, business person, please tell me what you want. What do you actually want? Okay, so you want it like this and you want it like this. They would spend 6 months writing what they wanted. And then we took 6 months writing it. What happened? When we pushed it after a year of the last deployment we did, well, obviously we missed something, right? Things didn't go as planned. That was how stuff was done. Essentially now is what we do is we write software and we push it out and we see it's sticking and we write more software and we take it out. Essentially, there's a whole aspect that I'm not talking about today, which is project management. It's fine. We don't need to talk about it. We're not there yet, right? We don't have projects that are shared between a bunch of people and bunch of dependencies. But essentially in companies, there is a thing called project management. How do we deal with all this complexity? Well, we break it down into what we're trying to add, trying to be very clear about what the scenarios are, what we're trying to do there, and then ship the stuff out. So it's very important that we iterate often. It's very important. I think the key lesson for people here, doing projects for the first time, or not, right? You're writing a piece of code together. When you're collaborating, it's still as important, right? When you're iterating over, let me add 4 lines here, then push and see if it works. I can add more. And the smaller the cycle is, the more in sync with your. Have you ever encountered a team member on a team project who, when you're trying to ask about, hey, you were supposed to write this file uploading thing, are you done yet? And they don't respond. And the night of the project, they suddenly show up. What happens? Does it work? Not always, right? So if you were collaborating together and pushing small changes, you would have known and would have rolled back. You're crying. I've cried. I've cried like that, exactly, right? So it's happened to you. What happened to you? Can't show up with anything. Yeah. Hey, for us to get marks together, let's upload this together, right? Like, hey, we're going to show this as our project because we did it together. Well, if you were iterating often and iterating slowly and doing smaller chunks, you would have known it would have worked. Or when you're trying to present tomorrow at the hackathon and say, hey, this is our software that works, and it probably doesn't work because you were not able to see your changes and work with the other person. So it's very important. Writing software is an exercise. It's hard to do. It's hard to make sure that everything works. There are a bunch of dependencies, a bunch of people solving problems together. It's absolutely important to iterate often. Absolutely important, right, Jose? Right? Because we fight that a bunch, right? So, okay. Hmm. Okay. Probably not relevant to us here. Maybe it should be. Maybe it's a good exercise to have, right? Maybe it's good to understand what this whole culture is. But it says encourage test-driven development. Okay. So companies, it's hard to do, right? So test-driven development, it says before you write what your function does, add 2 numbers together. Let's say as easy, right? write two functions, write a function that does adds two numbers together. Test-driven development says it's test-driven, so you write the test first. Huh? I don't have code. What do you mean? Well, that's fine. It says the idea here is to be, and I don't want to talk about TDD a lot, but the idea is that it's a shift in mindset that you write the test first. What do you mean by that, right? So essentially, your test fails. So the whole idea is red, red, red. Your tests fail until you write the implementation that says, hey, this is the function, adds two numbers, and then it's green. So it's red, red, green. The intention is for you to think about what you're going to test. What is your output? What is the intention of this code that you're writing? That's it, right? It's hard to do. It's hard to, because when we're learning these things in class, right? When we're trying to say calculate the volume of a sphere or whatever, you're like, okay, I know the formula, blah blah, right? This is 2 pi r squared, 2 pi square h, whatever, right? Cylinder. That's what you want to do, but you never think about how your function is going to be accessed and what are the possible types of input. What if somebody says, weird information like minus 2000, and you're trying to find an area or a volume? What's going to happen? It's going to give an output or it's not. You don't know. But if you start to think about it before you start writing the code, it's a great idea because you're going to catch it like, oh, okay, I see it. Very important enterprise software. Absolutely, right? Think about, hey, minus numbers is very important. Zeros are important, right? So you get to think about what your software is like, right? Test-driven development is an extreme example of it. People might adopt it, and it's all about people. It's all about you. It's all about you understanding what I can do with your other teammate and say, hey, this is what we want to do. I've gone to hackathons and said, hey, you guys want to do test-driven development? And they just laugh at me. I'm not even kidding. They're like, oh, whatever, dude. You sit down. You're too idealistic. But it's good because when I want to ship the code, at the end of the day, I want to be judged and I want my stuff to work. And it's a good idea. Plus, it's a good habit. Is it being widely adopted? Well, many companies are very strong about it, and other companies are like, we don't see the value. It's all open, right? It's all open. And all of this is subjective, by the way. Everything we talked about is subjective. It's all about you communicating with the other person, say, hey, I think code comments are important or not. Okay. But yeah, writing tests. Okay, automated testing. Oof. Definitely out of scope of this conversation, but automated testing, right? When you're shipping Instagram, when you're shipping big, huge software, right? That touches a lot of things. Well, if you have as many features, if you're churning out 7 features a release cycle, right? Then you have a bunch of features to test. Who's going to test them? How are you going to test them? Am I going to test it manually myself? No. So we're working with React, Vue, or Angular. You can write tests for the UI. You can say, hey, these are the tests I'm writing, and they're automated. That means that if I say that if you get an input value of tax or input value of the volume of a sphere, then I should see an output over here. And it should be correct regardless, right? So automated testing is writing lots of code that can be run in an automated fashion so that somebody's not clicking through, like, oh, let me check, click, input. It's never scalable at people at scale, right? Companies at scale shipping huge amounts of software. Automated testing is important because once you write that test case, you can always change the software and see if it passes, right? See if it passes, so it's already written a test. If it fails, you broke something. So it's great to write automated tests. I don't think I have more. This might be the last thing I'm covering. I'm good on time. Yay! Awesome. Yeah. So essentially, my intention was here to talk about these things that we don't really talk about. So I want you to ask questions, right? So we do collaborative software development. I've done it at different scales, from startups to big orgs. And yeah, if you guys have any questions that you want to talk about, hey, please feel free. This is the time. And yeah, Zach is going to get some swag out, right?
I have limited swag. I'm gonna try to get a few of y'all that did ask some questions, some shirts, but then it's just kind of a line, and then I'll give y'all out. I do think I only have like 30 shirts, so first come, first serve here in a minute. But yourself real quick. Shirt size, shirt size. Medium. Yeah.
While that happens, anybody has any questions? Horror stories. It's Halloween, obviously, right? Stuff that's gone wrong. Stuff goes wrong a lot, right? Yes, please.
So, have you ever had to work with an actual tester who tests your code and is like, oh, this isn't user friendly?
Absolutely. We're part of the same team. We're part of the same team.
Yeah. So, like, how do you deal with how do I say this?
Feedback? How do I deal with feedback?
Not even feedback.
Okay.
Per se, but like almost like intricate feedback where they're like, well, I want this, this, and this.
Oh, it's super annoying when they want specifically something. So you'll have testers that are like, this is exactly where the box should be, right? So sometimes you have tests that say, no, we didn't ship it like that. So if you're really good in a really good org, where it says, no, we know where the box is supposed to be, right? Because it's UX is very important to people. They're like, I don't like your font. So what you do is you go to the product, because you can fight about it all day long, but essentially there's a person called a product. There's a product team that says, hey, I'm making Instagram, or I'm making this B2B software, or whatever it is. It's somebody who represents the business and says, this is our product, this is what you're building. You go to them. You go to them and you say, hey, this is what I've heard. We've gone several rounds on this. What do you like? And it's sometimes always insane. Like they want it somewhere else, and you're like, oh my god. Happens a lot, but it's fine, right? We're writing software for the business. The business is the person you want to make happy, and if they want it on the left, fine, I'll make it on the left. But the QA guy tells you very all the time. Like QA person was always like, hey, this is not what they want. This is not what is required. This is not. They have a mock-up, right? The mock-up is completely different. They're like, hey, I'm dealing with CSS here. I can't really make that. They're like, no, but it says that you have to make this curve over here. And you're like, it's hard. Sometimes the product's like, yeah, it's fine. Sometimes they want you to do it, and it takes more time. It's fine. But feedback is, yeah, we get this iteration of, hey, is this what we want to ship? Is this what you want to ship? Is this what you ship? And then talk to different people, and everybody says yay or nay, and that's how it goes out. So good question. So horror stories. Anybody want to know horror stories of stuff gone wrong? Yeah. So we've shipped. Yeah. Yes, please. Where do you find them? So essentially, when in an org, there are open positions for QA testing, right? So some people are software developers from who want a different role. Testing is very important because people think that programming is where it's at. Actually, make sure that we don't ship that stuff that's not meant to be seen, right? A great tester is a great asset, right? So people would think about cases and scenarios where, so essentially, the old adage is QA knows more about your product, right, than the developers. Developers are like, oh, I just wrote some code, blah. But the QA is looking at everything from all the developers. There are multiple people, but they work together. And for QA people, they're like, those are open positions, and they have the requirements, bachelor's in computer science, all that background. It's a job out there. So people love to do those jobs. People are great at it. So it's a lot of fun. And yes, please. Leaks? What do you mean by leaks? You're part of the same team. If you have two devs, you have a QA, that you're three people, right? It's your team. They have a vested interest to working with you and pushing the right software out. So QA could be the product guy, and some small startups, product people have said, okay, I will look at what I asked for, and they are the QA. And you write your unit tests and everything so that there's no need for actual QA. But in bigger teams, when there's software connected to A, B, C, like one piece of thing, like let's say we work on payments, right? Payments goes through 17 different systems. From there, when the person said pay now, to click, multiple systems, right? QA figures out where the things are wrong because everybody's working on their own piece of software. QA has to know. So QA figures it out like, hey, this service, I think this is giving a bad response. And I don't like it when I put this input because they have to test everything. So QA's been great. Saved our bacon a bunch of times. So it's absolutely necessary part of the process. So. Okay, so horror story. We once shipped some software that cost us a bunch of money. You know why? Somebody clicked on pay, and we took money out of their account more than once. And one person, because you're paying, right? One person had like almost 17. Oh, is this recorded? So yeah, you mess up, right? You mess up where the person's one transaction was multiple because of a bug in our software. It's absolutely important to have QA. Absolutely important for them to know what our bounds of our system are when it goes wrong. And it's very weird edge cases. You're like, oh my God, really? So this code was still running in the background when it's not supposed to. And it only happened once in a while, and you weren't able to figure it out. So it's very important. But with money, it's very important, right? So you gotta break your functions down, make sure you know what they're doing, and then test and test and iterate small, because stuff goes wrong. Horror stories, right? And it's happened around Halloween, so yay! 5 years, 6 years ago. It's been a while. Yeah. Thank you, guys.